An OSPF router that sits on the fence between multiple areas is called an area border router. That term has significance. An area border router glues a backbone area to a non-backbone area. Area 0 to something else. And we need these if we have multiple areas. But we don't really need any special config. We just need some interfaces to be plugged into area 0 and some to be plugged into a non-0 area. Let's make sure we can configure an area border router. And R4 is going to be our area border router. I'm going to enable the backbone area between routers 4, 5, and 6. The backbone area will consist between areas 4, 5, and 6. The other areas that will exist right now will be area 1, 2, 3, 4 for routers 1, 2, 3, 4. Okay? So right now, let's set up the backbone area on the frame relay network. So I'm going to do something pretty sneaky. I've got a frame relay network, and I've got to make sure that this is going to work. So I'm going to do a SHIP interface brief. OSPF doesn't work beautifully out of the box on frame relay. So I'm going to do the following. IP OSPF network point to multipoint. I'm going to do that on 3 routers. This is the easiest way to set up hub and spoke frame relay PVC. More on that later. That's not going to work. There we go. I'm just preparing the topology to be able to form adjacencies because the media type doesn't want it by default. The neighborships aren't going to be happy by default. So I'm going to do 1/0, paste that in. Okay, so I configured this not as NBMA, the OSPF network type, but point to multipoint. The easiest way to get this up and running. So now that we have that, I want to configure the frame relay cloud as area 0. That's the point that I want to get here. And I'm going to be creative with my wildcard mask. So I'll do a show run section OSPF. We're going to see the existing configuration that we have. We have the command that we just typed in plus the OSPF area 134 that goes to the left of router 4. We want to the right of router 4 to be area 0, our backbone area. So what I'm going to do is this. I'm going to do router. I'm actually going to clear off the screen a little bit. You're going to see why in a moment. Router OSPF1, and I'm going to do a network statement that is going to be perfectly crafted, one that will match the network. Perfectly. I see that I've got a /29 mask for my frame relay environment. /29 equals what? /29 equals what? That equals, and I'm going to write that down here, you'll see why. 255.255 5.248. I'm going to convert that to a wildcard mask by subtracting it from an all ones mask. This is a pretty common technique, actually, but I want to make sure you've seen it. Just because it's common doesn't mean you've seen it. And this will work out to the following. That is the perfect wildcard mask, 0.0.0.7. So take your subnet mask, that's my /29 there, convert it to a wildcard mask by subtracting it from all 255s, plug that in, and away you go. So .7 was the result there. I'm going to do area 0. I'm going to take that, because it's so beautiful, we're going to plug that into our 5 and 6. we're going to wait for that neighborship. Looks like we got some good neighborship already. So does R6 see some routes from OSPF? It does. It sees OIA routes. These are routes outside of my area, outside of the area on which this router resides. Router 6 is only plugged into area 0. It doesn't have connectivity directly to area 1, 2, 3, 4, which is all of the routes that exist really at the headquarters site. Okay? So interpret it this way. IA says the route is inside of my area. Just an OIA says the route is outside of my area. OIA says the route is outside of my area. And a plain vanilla O says the route is inside. Okay? So that's how to interpret the routing table, but things are looking good. And we've configured router 4 as an area border router. And I can see this simply by looking at my OSPF config. And I can see that it's got interfaces in multiple areas. And I could also look at this and say, Show IP protocols even tells me I've got an area border router.